All right, we are in section 6-5, applying systems of linear equations. And I will tell you this section on this video is going to be a little bit different. I'm not going to work a bunch of problems because if you want examples of how to work the problems, you can go back to previous sections. What we're going to talk about in this section is the best time to use these different methods. We've got 5 different methods that we've used. Our graphing we used in 6-1. Substitution was 6-2. Elimination using addition and subtraction was 6-3. Elimination using multiplication was 6-4. So we've got 5 different methods right now, and you've been using each of them, and I've told you already that you can interchange the methods sometimes. Well, this section we're going to find the best method to use. Now, I want to let you know right off the bat, you can use any method. It's just some methods are going to be a lot easier or a lot more work or a lot less work in order to use. So let's look at these reasons. First off, graphing. The reason why we would use graphing, you know what, I'm going to switch my tool. Instead of underlining stuff, I'm going to use this nifty little hand. Whee! The reason why we would use graphing is to estimate solutions. Estimate is really important because you're not necessarily going to get an exact answer with graphing, or sometimes it's not going to come up on the grid lines. So since graphing usually does not give an exact solution. So graphing will definitely tell you, you can definitely use it if you want to find out what type of system it is, whether you have one solution, no solutions, or an infinite number of solutions. It's really great for that, but it's not great for precision. Our substitution method. Substitution is really great if one of the variables has a coefficient of a coefficient of 1 or -1. So what that means is that when you have something like x plus 4y equals 13, because our x has a value of 1. So you can really easily swap it out and change that to x equals -4y plus 13, and boom, you can substitute right away. To use elimination by addition or subtraction, it's pretty much the same thing. You use addition if one of the variables has opposite coefficients in the 2 equations. Like for instance, if you have, let me write this down, if you have a -3x in one of them and you have a 3x in the other equation, and it's the opposite for subtraction. So if you have the same coefficient in both of them, like a 3x and a 3x, then you subtract, if you see that. And when you use multiplication, you use multiplication when none of the coefficients are 1 or -1, because then you'd use substitution. And neither of the variables can be eliminated simply by adding or subtracting. Basically, you use multiplication when you ain't got nothing left. You don't have anything. Multiplication is the last one that you use, so I will put last resort. This is your last resort because it's the most complicated method, and because it's complicated, it's a lot easier to make mistakes. So you only want to use this if none of the other methods work. I will add one thing to this. There might be certain solutions, certain methods that you like better than others, and sometimes if you like it and you like it, sometimes it's better to use that than one that's actually easier to use. If you like it, by all means, use it. Use the one that works for you. But some of them, like I said, are going to be easier or tougher depending on the problem. Okay, so here we have 4 separate problems. This is page 365 in your text. These are the guided practice problems. So what I want to do on these, I do not want to solve these. Like I said, you can go back to previous sections to see how to solve them. Instead, I want to see what the best method to solve these is. So let's take a look at this first one here. We've got 5x plus 7y equals 2 and -2x plus 7y equals 9. Well, I can see right away that we have 7y and 7y. So what makes perfect sense to me is elimination by subtraction. If I subtract one of the equations from the other, then I'm going to eliminate the y. So I think the best solution here, or the best method here, is elimination by subtraction. The next one over here, I have 3x minus 4y equals -10, and 5x plus 8y equals -2. Well, here I don't have anything that I can eliminate simply by adding or subtracting. I also do not have an x or a y with a 1 or -1 coefficient. I have 3x here, -4y, 5x, and 8y. So really, I go to what the last thing is that I have available, which is multiplication. And you see if I would multiply this first one by 2, so I'd get 6x minus 8y equals negative 20. The negative 8y and the 8y would drop out. So I'm going to say that this one, the best method is elimination by multiplication. Now let's look at the one on the bottom left here. I've got x minus y equals 9 and 7x plus y equals 7. Well, I could go a couple different ways here. I know when I have x's or y's with a 1 or negative 1 coefficient, which I have x, I have 1x, negative 1y, and I have 1y. I know that I can always go for substitution, because all I would have to do with substitution is I could add y here, and I'd get x equals y plus 9, or I could solve for y, or I could solve for y down here. There's several different ways that I could do substitution on this one right here. But you might also see that I have a negative y here and a y here. So it would not be wrong if you said elimination by addition, because when you add these two equations to each other, y is going to drop out because you have a negative y here and a positive y here. So really, I would not say that one of the answers is better than the other. This is one that's going to be your preference. So the last one that we have, 5x minus y equals 17, 3x plus 2y equals 5. I'll give you just a moment to see if you could figure out what the best method is on your own. So once again here, I think there are two different ones, because you see here we have a negative y, so we could solve for y and then use substitution. However, I know a lot of people get annoyed by substitution, and if you had to solve for y equals 5x minus 17 and put that into this equation right here, 2 times 5x minus 17, man, that's going to get kind of hairy. So a lot of people don't like substitution. So a lot of people would see that this negative y and this 2y, if you multiply the first equation by 2, which is elimination by multiplication, if you just multiply the first equation by 2, you get 10x minus 2y equals 34, and that negative 2y and plus 2y will cancel each other out and be eliminated.